Okay, my friends, I am going to go right for the heart of the matter. This is a geological formation. And you see that hole right there? You see that texture, this color, and the separation layers? This is a rock that I have here, and there it is right there, and it's in the microscope. And these are the layers that you see, basically like these layers, only this is from a gigantic area. And I am going to show you that there is no difference. They are both biology. These are the membrane layers in a piece of tissue. And here it is right here. I'm going to show you in the microscope. It can't be missed. Now, what is this? That's a picture from Yale University. Dropped the name geology. Yale renamed geology and geophysics to earth and planetary sciences. That's because I reported all this information to Yale long before this. And they're sort of easing their way in. This is nothing more than what you're looking at right here. Only it's big. There was gigantic things and there were small things. It's just the way it was. And I'm going to show you this in a microscope. You'll see these tiny little holes and these layers of tissue, and that's what it is, layers of tissue. And this also is the Grand Canyon, is layers of tissue. Okay, shocker du jour, but it is true. This looks like a piece of cake or something. However, this is a membrane. If you can see this little fuzzy stuff, and it is fuzzy, I'm going to show you it is fuzzy. And that is basically right at the level of the skin, where the skin can pull and twist and do this, I believe. Below that is the layers of membranes that protect you from invasion, or protect this creature, whatever it was. Now this is a big chunk of stone, but you can obviously see these layers are not sedimentation. You see that? You see that? That's not sedimentation. This is a fluid-filled highway, and there are several of them. There's not just one. I realized there was one that was never known about, and it facilitated this type of fossilization. I wrote a paper called Fascia, which is this stuff, facilitated fossilization. So let's look at what I'm going to show you, because this right here is that. All right, that's in the microscope. Now I have this also in the microscope up above here. And I have to turn the lights off. I'm going to look at it. I'm going to look at those little filaments. Remember I told you these little fibers? You see that? That's just fuzz. That's literally fuzz on top of there. I know. You see it? That's just the fuzzy stuff. You see it? And the rest is membrane. There's red and black and, you know, fluids and all kinds of stuff in this membrane. This is just the very top layer of this membrane. You know, this runs about to here, from here down to here. But this is a pretty thick membrane. So we're going to look at it in a microscope. Don't forget, that's what we're looking at, is this, and we're going to be seeing the fuzzy part. Okay, my belief here is that this is skin, but I'm not certain of that. It could be fascia down in an organ, because I didn't cut this piece. It was sent to me by my good friend Greg Morrison, and he sent me this block and said, what do you think about it? And I will say, wow. This, I believe, is basically almost like the layer of skin, and inside the layer of skin, as it erodes down, you can see these little, like the little ball-looking things. And then you see all these fibers. So we're basically coming across here, and we're getting deeper and deeper into the tissue. And I believe here is where all the skin is being sort of held together. And these are the things that stretch and pull and come back. I believe, that's just my opinion at this point. But I do believe, well, there's no question whatsoever, this is a membrane, and this is the top of the membrane, and below it is that stuff. All right, so don't forget, that's the fuzz that we were just looking at right there. All right, and that's, I believe, like the top of the skin. And then you got, your skin, and then you get down into what protects you from the rest of the world, which is all these membranes. I mean, there is so many membranes, they have no idea how many membranes there are. I'm not kidding you. This is the fluid-filled highway, but I think there's more. I think that is one as well, and there may be another one. And they are the conduits that transfer fluids called lymph fluids around your body to protect you. And inside here is the enzymes and the bacteria that actually do all kinds of work in your body. There's so much going on here, it's hard to believe. But that is what membranes are made of. They're not just a couple of layers. Okay, my friends, shocker du jour. This is coral. And this is red blood, and this is a cavity here, because this is a heart. All right, that's the cavity and all the tubing and the cavity inside the heart. And these are the ventricle walls inside there. And I'm going to show you something that's kind of funny. I thought it was really funny. You see this? These are like the ventricle walls, and all this stuff is from a heart. And coral live on body parts. And this bottom here, you see this? You see these 3 holes? That one, that one, that one. That's what's in a heart, is there's 3 holes at the top. And that's where the blood comes out. You see it? All 3 of them have blood in them. That's where the blood comes out to go to through the tubing of your body. And here's the inside of the heart right here. And that coral lives in body parts. And this is the ventricle wall. This is a heavy-duty ventricle wall. And this is coral. And those are the 3 dots. Now, wait till you see this. This I thought was really funny. I'll show you this. Hold on. Stay with me, my friends. Stay with me. I have to admit, this is kind of funny, because this looks like just like a face. It looks like the guy's nose, his mouth, eyeballs, and everything. And that's what people do. Oh, there's no question. Absolutely no question. Well, that's a heart. I showed you that. But let me show you this. That's nothing. All right, what we got here is a failure to communicate. Now, I showed you those 3 holes. You see this? This was from Myron. I'm not going to get too deep in it. I'm not going to just be disrespectful, but he's seeing these 3 sinkholes because he's just been examining a heart, which is there's all the red blood from the heart. And he said, wow, look at these 3 sinkholes. I wonder what that could be. And then he goes down to look at them, and sure enough, they're layers of tissue. So he's asking about those, and here we have them right here in a heart. There's the bottom part of the heart. And it's all eaten out now. And the coral has gone on, but those are the 3 holes like Myron was looking for. These 3 right here. You see? And inside here is all well, you saw the blood that's in here. Now, it's the same thing happens with what they call stromatolites. Those are tendon anthesis, and I'll show you that in a second. But this was really kind of funny, because what I posted on was, hold on one second, I'll show you. All right, this is just fabulously cool. I am again looking at the heart that's from the coral. Now, this was what I was posting on about this particular formation, which Myron was asking, what is it, some other process creating these crazy patterns, and he doesn't know, and he's speculating a bunch of stuff. It just wasn't right. So, of course, I commented, and of course, nothing happened. Now, my claim is that this is tissues of primarily muscle wrapping around a huge artery. And I have one here, which also is huge, not quite that big, but mine is right here. And I think this also came from Greg Morrison, this huge artery. And that's the blood that's in it. And that thing is big. It's right here, hold on. And it's heavy. And if you were looking at Myron's picture, first of all, this is what I polished a little piece here so you could see the layers of membranes, and it's exactly identical to what they are in an artery wall. It is no difference whatsoever. And this is it right here. That's this side here has most of the blood washed out of it, but there's a lot. All that red stuff in there is blood. That was red arterial blood. And now it's converted primarily into sandstone because silicates attach to blood very easily. All right, and they create these sand, basically. And the redder the sand, the bloodier the blood when it attached. Now, this, again, is this right here. All right, now, what is this? That is what is inside those layers of tissue. So here you have this, which is nothing more than this right here. This right here, sticking down in the center here with this real thick edge around it right here. And that stuff right there is nothing more than blood, I believe. You see the difference? And then you got that ring around it, and then you got all those. Those, I'm almost certain, are muscle sarcomeres, because he shows them a little better in a different shot here. All right, here's what they look like up close. That's this right here. That's this right here. Only it's still got a lot of the blood. And the little tube in the center is just like that. And then you get your tissue wrapping around it. So this is coming out right in the middle, just like that. So what does this tissue look like? You see these little bands? Little sawtooth looking things? Can you see that? Those are, I believe, muscle sarcomeres. All right, so you have an artery with all the red blood. I'm pretty sure that's red blood. I'm going to show you one. Well, as a matter of fact, I'll show it to you right now. I have it in a microscope. It's in a heart as well. All right, you ready? I got to turn the lights on. All right, don't forget what you see in here. You see that little hole going inside there? Going down in there? Watch this. I got to focus this here. All right, here we go. We're going up to the Z microscope. Now, this is that heart. And these are some of the little tubing that's going in, which are veins, well, arteries. Arteries blow out. Let me see if I can find. You see down in there? These are little arteries that are running all through. Here's you got some yellow and black. That's blood. The red, of course, is blood. Here we got some yellow and black and red and brown and all those colors at the same time, which is blood. And then, of course, you saw the inside. It's all coated with the red blood from the artery. all of these little tubing spots are because here it is right here. Look at this. This is basically what he was showing. Now, look carefully at what you see here. You got to look at the details. This is really like surrounded by this gooey looking stuff. That's cardiac muscle. Now, I'm sure it is. And this is how the plumbing goes through. Now, here's the one that Myron was showing, which is basically the same thing. Only this one here has a little more defined layers around it. It could be in a whole different area in the heart. But there's so much blood flowing through the heart to service all these muscle sarcomeres. It's just amazing how much blood your heart uses to pump blood. It works both ways. Okay, so again, these are fabrics. This is a fabric. He says it has orientation. Yes, they're muscle sarcomeres. Those things pump your blood, your heart. They're muscle. And they're in layers, and there's a slurpy layer in between each one of these, which he points out here. And that layer is a phospholipid membrane layer, basically slides a synovial sheath, leucine-rich proteins, that real slippery stuff. And that's what they guide on, and they squish all day long. And every one of these is a separation layer. Now, inside this way, it was the artery. And I'm sure that could be checked. I mean, Myron's a geologist. He should be able to take some samples and look at this. If he's making claims, my claim is that this will primarily be blood. All right, and you don't have to take it from the surface. You chisel a little piece out, drill inside there, and you take it out. That's what I do. I drill inside of them and take them out. I don't swab it from the surface, obviously. Once you get deep enough in there, it's uncontaminated. And this will be arterial blood. There's going to be something in there that you could test. So that's what I would say, is this. I would drill in there deep enough so it's uncontaminated, take a swish it out. And, be careful, obviously. You wear all the little gear. This, I would get a real close-up and look at the sarcomeres, which are those little blocky sarcomeres. You'll be able to see those quite easily in this. And I can see them already right from here. They're obviously apparent. And this is just a goop, just like the center of this thing is goop. You see that? That's this stuff here. Right here. Then you get this is right up around here, this heavy duty jobber. And then you get the muscle around, and the muscle has, some of it's eroded away and flaked off and broken off out there. I think that's a pretty good explanation of what he's got there. And I think this is a pretty good explanation of what the world is made of and the universe in total. Is this. This is nothing more than that. No difference whatsoever. Zero difference. Every layer here is a layer of tissue. Every layer is a layer of tissue. Just like this. It was in a creature's body, just like this. The creature was gigundal. Huge. Bigger than gigundus. Every layer is one of these layers. You know how many layers there is there? In the microscope, there's literally hundreds. And down below this is just the skin layers. There's a creature's body down there somewhere. Now, a lot of the guts have been ripped out. I think this whole area, the Midwest and the Grand Canyon specifically, was basically, I think it was an impact area at one time from, I believe, probably from Venus, when it almost hit us and just gouged the hell out of that area, just like it did to Mars. That is what was written in the ancient text. It had almost hit us and really caused all kind of catastrophe, huge floods, which are very, very obvious. And then it hit Mars and destroyed Mars, and that is extremely obvious as well. Okay, I'm pretty sure I showed you all these little fuzzy things that are coming right out of here. That's like fuzzy stuff. I don't know if you can see it. It's like a fuzz coming right out of the top. You see those little scaly spots? That's where those fuzzy spots are. And what they are, I believe, they are the attachment to the skin, literally to the skin, so the skin can float around. And I'm going to show you in a microscope, because I use my belt to show this. There's a million little fibers, and they're each attached to a little ball. Now, I don't know if you can see that in here. Well, this is about the best shot you're going to see. I believe this is just like the skin, and these are attached to little tiny balls that are in here. You really can't see them all that well because they're so small, but I'm going to show you in my belt. For some reason, split cowhide seems to have some pretty good sized balls. These might be the balls, I'm not sure, but they are definitely, there's a fuzzy strappy stuff coming out of there right above the membrane, which I'm sure that relates to the webbing of the tissue that's right below the skin. You see that? This is the webbing that is in this area here, like this webbing stuff is in this gooey area where it has all this floppy stuff. And those little fibers hold the skin together in a fabric like that. And each one of those little fibers attaches to one of those little balls. They're everywhere. I mean, there's just millions of them. And then below that, you get into your fluid-filled highways and your membranes, and then down into your tissue. But I believe that is right here, right in this area where these straps are. Now, this is really, really down there looking at what's under your skin, and these are the balls. All right, and they get enormous as I talk about these enormous things. This right here is nothing more than that right there. The skin is at the top, right there. The red fleshy area is right here. The balls are hard. They're hard, but they still got a lot of meat on them. They really have a lot of edible stuff on them. And what happens? It gets washed away, washed away, washed away, washed away. The balls fall. The rest of the stuff turns into mud, precisely as seen here in the United Kingdom. Washed away, washed away, washed away. They come down as balls, and they're still edible. So something starts eating them, and they call them stromatolites. Something is in that flesh already that wants to eat these things in salt conditions. And eventually, when they're all eaten up, they'll be like this, milky marbles. The hard core will be inside, and there'll be nothing left to eat. Just like I believe I showed you on the coral. That's a heart. Those are the 3 valves in the heart. Those are the chambers of the heart. It was eaten by coral, and it was done. Once there's nothing left, see you later, alligator. Some of them might populate in there and start growing in there, but they need something to eat. Some of them filter and absorb things as they filter by, yes. Some of them are just eating what's left over in the heart, which was blood. And then by the time they're all eaten, they lay here. If they don't get eaten, something eats them and grows on them. And what might that be, Roger? Well, it might be this green moss up in Alaska where they're melting in fresh water. Every single one of these, 100% of them. 100% has that green. The only possibility here, mysterious things scientists still can't explain. Well, I'm explaining it right now. It's still got edible stuff in here. And what happens is these roll all in the same direction. They move because they're rolling to get the stuff. There's no roots on these. They just roll. So they want to get the stuff that hasn't had any sunlight over to the sunlight. That's my opinion of it. And they all move in the same direction, and there's no question in my mind, but they've been studying these for 20 years. And when you cut one of these open, what you see is one of these balls inside of it. It's incredible. They don't understand this, but you got to open your eyes big enough to see with mud fossil eyes. Like Mars. These are the Mars blueberries. Identical, no difference whatsoever to the Moki marbles. This is basement layer of skin, very tough. These are the stuff that rode on top of there so your skin can do all that kind of stuff. And then above that was actual skin. Just like we see here. Now these are in salt water, but there's the mud, same stuff. And here the mud would have been here, but then it washed away. So this is reality. And of course Yale renamed geology into earth sciences, earth and planetary sciences, which is this, which is that. I show this very, very clearly. They understand what's going on here now. And I presented all my research to them long before they presented their paper. And my research had DNA and CAT scans and everything else. And they claim the only thing to preserve was slimy little creatures, and that's just not true. I have this one hair follicle is from some kind of creature. It's two inches wide. That's the sebaceous gland. That's the pili erector muscle. These are the hair papilla on the bottom, these two little dots. And there's the shaft coming right up the top. 2 inches wide. So, and my other ones are DNA tested, CAT scan, a lot of stuff. So it's not like they don't know this. It's just that right now they're hiding from the truth as far as I'm concerned. I know that for a fact because I slaughtered them with emails, and it didn't work out well at all. It was a very, very contentious, and still is. And I have one particular person down there that I blame for it. And I was told that he's the one I had to convince one way or the other, and he refused to examine. So that's Yale University. Was not happy whatsoever, because we are being denied our true reality. They're showing this. They're showing that. They realize now this is earth sciences or planetary sciences. Well, I presented all my stuff to NASA as well. This is the same stuff Yale's showing. It's the same stuff I have here. It's the same stuff they have on Mars. Muscle on Mars. It's the same stuff they brought back from Bennu. It's this heart muscle. And Mars was impacted by Venus, and here's the evidence of that. Here's Venus. That's a discharge from Mars into Venus. And I know why, because Venus spins backwards, which makes it extremely attractive to the white energy particles. That's part of dipole electron flood theory as well. This is a very, very strange anomaly, a backward spinning planet colliding with a forward spinning planet. Very strange. And that happened with us and just set us ablaze, caused a great flood and all that stuff. And then it came around, hit Mars. All recorded in the ancient texts. And let's see if we can find that on Mars, which we can. And here it is right here somewhere. Mars, where are you? There you are. Look at that. That's wider than the United States. That is an impact. There's no question about that. That didn't just grow there for nothing. And at the same time, all of its discharge is a magnetic field right into Venus, just created that arc welding scar. And it sucked all of its atmosphere off at the same time as well. And it never came back because the plants have to grow to make it come back, and there's just nothing left to make the plants grow. So there's not enough atmosphere to create a magnetic field. So it has no magnetic field. It has no gaseous atmosphere to create rain. So it's a dry, dead, red planet, and that means there's no rain, no raindrops ever fell on here since it was wiped out by Venus colliding. This is muscle sarcomeres, and this exact same stuff is what they just came back with from Bennu, which is a heart. It's in space. They brought it back. It's got the DNA. It's got all the signatures of life, 100% of the signatures of life, and they just can't accept it because it's just too big for them to get their eyes open wide enough. It's undeniable. It has all of the anatomical features of a heart. It has all of the signatures of the blood and everything. They say, oh, maybe that brought all of that stuff to Earth so it could turn it to slime and create something. No. That was from battles in the heavens. It was written about in the ancient texts. Every single culture had the same story. And Mars was destroyed by Venus. And we live in a total different realm than we thought we did. Totally 100% different. And you have to go back to the ancient myths. Examine them. If you don't believe them, good for you. If you believe them, good for you. Matters not to me. But when we are denied to even think about them and discuss them, which you could ask your professors about this, millions of years to do this? No. That was a creature died. Huge, gigantic creatures. I'm not saying they're not huge and gigantic. Absolutely they are. This is just the membrane of this creature, whatever it was, and it was big. On membranes in us, you could hold this up and look right through it. They are sort of opaque looking, yes, you can actually see somewhat through it, but in us it'd be just like a piece of plastic. You just hold it up and you make a window out of it, just about. That's how thin these things really are in us. Okay, remember I showed you the heart sarcomeres here? These are supposed to pull in. This is connective tissue, very tough, does not erode. This is the red muscly stuff in there. It erodes very easily, turns into mud if it was wet. Here it turns into dry, dusty clay, like dust. But it's made out of red blood cells, because that's the artery stuff. Now, what does heart muscle look like? Well, that's heart muscle. This is heart muscle. This is from a heart attack victim. And they're sarcomeres. And inside the white layers are the connective tissue, and there's thousands of them. And the black ones or the dark colored ones, red primarily, are the gooey stuff that pulls. Now, those are both muscle sarcomeres. Well, guess what? They went to Bennu, and they landed on Bennu. This is National Science Foundation, Smithsonian, all of them, and we're really working on this. It's been a couple of years now. They brought it back in 2023. I knew what it was immediately, and here's what it was. I didn't have any idea they would get deep enough to pick up the muscle sarcomeres, but they did. These are the muscle sarcomeres. And these two layers here are the phosphate surprise. They say, wow, there's phosphates in there. Well, because of phospholipid membranes. They're these right here. There's one here, one here. Although this is muscle, but there's always membranes, one on each side. So you got a membrane, muscle, membrane, muscle, membrane, muscle, membrane, muscle, membrane, muscle, on and on and on, forever and ever. And these are what the blocks look like, which are the sarcomeres. And here's what they look like in the heart muscle. No difference. And what does Bennu look like in its entirety? Well, Bennu looks like a heart. And there's a valve right there. There's a valve right there. And there's a big, big one right there. This is Bennu. And they hit it hard and went deep and grabbed muscle and actually brought muscle back. I was shocked to see the muscle. That blew my mind. I knew they were going to come back with blood, but I had no idea they'd get down deep enough to actually grab muscle. And you can even see the bundles here. This is looking down at this right here, which is like on a flat, chipped off place. So you can see the muscle bundles are laying on top of this. This is looking into this chunk of muscle. And these are the bundles. See the little bundles? And they go all kinds of like this way and that way with the heart. It's cardiac muscle is different from skeletal muscle. And that's how they bundle. And this is a cross cut here, basically. And we're seeing the sarcomeres sort of laid out. Here we're seeing them kind of tangled into a bundle. And I mean, and it has everything. It has the RNA, the DNA, the uracil, 16,000 organic chemicals. It's got all the nucleobases. It looks like a heart. This one here is Psyche, is another heart. This is a heart. That's a tube coming out. That's not a crater. That's a tube. That's a tube. And these are valves. And they're exploring this because they know it's saturated with metals. Blood is primarily made of metals. Once you get the plasma out of it, out of the moisture out, you end up with a lot of metals. And they have to know this. And this is what the heart looks like. And those are those three little, remember I showed you this? Hold on. Where's the, here it is. That's this right here. You see the valve, the valve, the valve, and the other one right there? That's what a heart looks like. See that? And inside this side is where the chambers were, where all the red blood cells are in here. I showed in the microscope, or I'm sure I did. I can recall doing that. Now, this is what's in space. This is what's driving them crazy, because my stuff is CAT scan, DNA tested. I had all my specimens. They can be tested again. There's no problem doing this. And these things are so over the top that it freaks these people out, and they're spending tons of money walking around in circles when they should be talking to me, and we can discuss it. If I'm wrong, I'm wrong. But that doesn't mean that Yale, which I gave all my research to I started with them probably 2013, 2014, 2015. And in 2015, I had all my work was done. Because they just dismissed me, and I said, well, I'm going to prove this is true, because it is true. So I did the DNA tests, the CAT scans, everything was done by 2015. I wrote the paper. It's called Fascia Facilitated Fossilization. Fascia is the coating layer of the membranes, and it facilitated the fossilization. And I had things DNA tested like this right here. This is a human lung, and it is human. It's DNA tested human. You see how flat that is? That's because it was in the Great Flood. And the fascia, what happened is the creature died. A human being died laying flat like this. And I know the whole creature was here at one time. You say, whoa, how would you know that, Roger? Well, because the heart was there. You see that? And not only that, you see that? That's called the aortic arch. I believe it's called the aorta arch or aortic arch, something like that. That's where the heart was. Done. And it ended up separating on the fascia planes. All the flesh boiled off. All the flesh boiled off and turned to mud. That's what all the clay is around the world. It's what the mud is fascia. That's all it is. Well, when I say it's all it is, it's not all it is. All the flesh, basically, a lot of the flesh boiled off. Because the oceans boiled. During this event, when Venus almost hit us, the oceans boiled, and all the ancient texts talk about this. The oceans boiled, and boiled very, very seriously. So it's time that we have to reread the ancient texts and see, do they make sense in the context of mud fossils? And you will find that they make extreme sense, even much more sense than we even could have possibly imagined. As I'm showing you these giants and so forth, and Venus smashing into Mars, and the actual electric discharge. That is an electric discharge. There is not a single welder on the face of this planet would say, oh no, that's not electrical discharge. They would say 100%. That is some kind of electrical discharge. And I would assume, and I'm not positive, I would say it hit here and went this way. And that was the snap away. This, instead of this being the bash in, and that being the snap away, but I don't know. All right, but one way or the other, it hit and then had to come away. So we know one is one and one's the other. Which one? Je ne sais pas. I don't know. But I do know that's arc welding. And if you find me a welder that says it's not arc welding, find me one. Just find me one. Find me one. I gotta think that this is so intense, that this would be the impact site. That's the real, this is some serious arc. And then it sort of dissipates, and then it sort of pulls away. I would say that that's what's going on there. And at that point it leaves. But in the meantime, we sucked out all of the juice out of Mars and left it dead and just floating in space. So you would say, well, Roger, how would Venus hit Mars? Where did Venus come from? Well, it wasn't here. It wasn't in the solar system. It was not here. And you say, well, where did it come from? I said, well, it came from Jupiter. It was born from the feared god Jupiter. And you say, oh, come on. I said, well, let's take a look at the great red vagina. I mean, the great red spot, which is a female body part called a vagina. Now, first of all, you would say, Roger, Jupiter is a male god. And I would say, read Ovid, O-V-I-D, Metamorphosis. They could change into anything they wanted. And it's extremely obvious that Jupiter, the feared god Jupiter, gave birth to the fiery comet known to now as Venus. Now, if you don't want to see planet porn, don't watch, but I'm going to show you a great red vagina on Jupiter. All right, are you ready? Here goes. Boom. And here is that great red vagina. All right, so, I mean, you got to sort of know your way around a vagina to understand this, but I do, fortunately. Now, there's all kinds of tissue up here. There's labia majora, labia minora, this and that, the clitoris. Now, and then, of course, you have the urethra, and then you come down with the vaginal canal and what's called the vaginal ripples. And that is the shape of a vagina. Now, it is in a turbulent zone on Jupiter, and it does, the wind comes this way and wraps around and swirls behind this, which I will show you. But this is literally the hairline. And this is literally the tag that tags this body part into the main body. In the human body, they have exactly the same thing. It's exactly the same. It's a little strap that comes up and a little button that tags it in so that it can move around a little here and there, but it comes back to where it's supposed to be. Basically, everything in your body is anchored in one way or another to stay where it's supposed to be. This is a mound. It's the Venus Mons. And it has to come through the atmosphere of Jupiter. And when it does, the clouds swirl around it. This is not a great red spot, it's a great red vagina. And that's where Jupiter came from, Venus came from. Venus fits exactly that size to come out of there. Exactly. Okay, I want to be sure I don't forget to show you this. This is the skin. This is the fluid-filled fabric that has all these little tiny balls and all those little straps. Now, what are those straps? Well, there's a gooey one, the pink one, that's stretchy and gooey and then pulls and gets flat, and then it's basically a rubbery sort of substance. Then you got the brown one. That's a different story. That right there is like a spring. And that's what it wants to return to, is that sort of a form, basically. The ball is the anchor that anchors the spring. All right, so you're with me now? We got skin. Under the skin, you got a little bit of a fluid layer that sort of separates you, a membrane-ish thing. And then you get into this webbing. All right, now, where did we see that? We saw that in the United Kingdom right there. All right, now, let's take a look at that webbing. Let's look at this up close. That's the skin. Now, you see this red layer right here? That is basically a fluidish filled layer that we saw up here directly under the skin, where the skin anchors basically, and there's between that and the anchors and so forth, it sort of floats and it's a little bit floppy at that one spot, and that's, as you age, that's why it gets real floppy on that outside very edge. It's not anchored as it is down here. But anyway, down here is what we're going to look at. So we got skin, and that's some serious skin. Below that is the fleshy stuff, and these balls are in these walls. And as that erodes, these balls are dropping down into what they have just created, which is mud. Now right there you're going to see, that is where a strap attached. That little round spot was where a strap attached to that, which was one of the brown straps that I showed you before. And they have them, and this one I think is here. They will all pretty much have that here or there. But in addition to that, they have whatever this kind of mossy looking stuff is. That is literally eating the fleshy stuff that was still edible when it was in the wall. These are not stromatolites that just popped up here miraculously. As the stuff erodes away, this is what the leftover is. Exactly like the Moki marbles. Right here. This is this. Same difference. No difference whatsoever. However, this is eating what's edible here. And sooner or later, there'll be nothing edible left, and you end up with this. Which are just like, they're like stones. And they're mostly metals and things. They're the central core of these edible balls, which were anchors in edible skin. And here they are, the little balls. You see how dense they are? Look up here. There they are right there. This is all biology. It's all biology. It's a little hard for the average mind to expand into this realm, but it is true. Now I'm going to show you these balls attached to these straps, and I'm going to show it to you in my belt, which is in the microscope right there. Now hold on. All right, I showed you all those little tiny balls. Every shiny spot here is a ball. And the reason they're not big round balls is because it's crushed. They rolled, this is a split cowhide belt. These are the anchors, and there's straps running between every single one of these, as I showed you before, in the anatomical picture. So, are you going to take my word for it? No, don't take my word for it. Say, Roger, show me those straps. And I said, well, you don't have to take that kind of attitude with me. No, I'm just kidding. I am going to show you the straps. Are you ready? Because I am. All right, so let's play with the light a little bit first. I'm going to turn the light up, and we're going to see those balls. And all of this brownish looking stuff is straps. Now, I'm going to move it over towards where the belt buckle goes through, and you can see the straps. See the straps? Every one of those is a strap running to every one of those balls. You see them? And now, if you could see how many straps, how many fibers there are in each strap, which we will, let's go take a little closer look. There's just thousands of them in every strap. All right, every one of these straps is attached to a ball. This is one that's fairly complete. But in that strap right there, there is literally, I would say probably hundreds and hundreds, possible thousands of tiny fibers. Now look over here. Here's a good spot. You can see how fibrous this stuff is. You see how tiny these fibers are? And the only reason you can see them is because they're all stretched and pulled out because of that. Look at that. Look at how many fibers are in that one particular fiber. It's incredible. I have microscopic shots of these things that you just can't even imagine how many fibers. So think of how strong a leather belt is because of this particular fiber network. And this is all collagens. They're bendable. They're, collagens and kerogens and whatever they call them, but they're all biological connective tissue type things. And they're anchors in the body. And that's tough stuff. And that's my belt. And if you get away from the belt buckle, you get right down to where there's just nothing but these fibers and the balls. And a sideways look on this is very interesting because you can see the pattern of the layers. Yeah, I just got this about Devil's Tower. It's a tree, and they have a big claim about, this is a guy, a nice guy, says you'd be interested in this. They discovered roots under the Devil's Tower. New discovery will change history. And it goes on about these roots. Well, I sent back to him, I said, that's crazy. That is this right here, the root development of vegetable crops. That's corn. Sweet corn roots at 8 weeks. That's what happens. These people, they can't, these tree people, they say, oh, that's a tree. It's not a tree. I know exactly what it is, and I will show you in the next video. It is not a tree. And trees didn't make it through the Great Flood. Flesh made it. It boiled. And it left the flesh basically intact, boiled out, cooked, more or less. So, all right, I'm going to leave it at that for today, but I think I've shown you enough to make my case that it should be examined and not just laughed at. And all these things are pretty serious. This is a rock, and is not a biologist, anatomist on Earth that could look at that and not understand that is a membrane. And all my mud fossil work pointed out that there's membranes. Actually, here it is here. I think I got a shot of it. Here's right here. Meet your interstitium, Newfound Organ, 2018. I wrote the paper on this in 2015, that this was a fluid-filled network, fluid-filled highway, surrounds every organ in your body, every muscle, every tendon, every organ, everything. And I think I have found that there's maybe more than one fluid-filled highway. There may be two. One going out and one coming back. I'm not sure. But when I see in the microscopic shots, I think this might be one and this might be the other. Although this could be just the hydrophilic and hydrophobic heads that are between the phospholipid layers. They have to have some chemistry done here. See what the chemistry is here and what the chemistry is here. But what a membrane does is it keeps stuff out that it doesn't want to let in, and it lets stuff in that it wants to get in. It has to go both ways. You cannot have a membrane one way. However, when a guy dies, different story. The things that are still allowed through that membrane will still be allowed during these conditions. They still penetrate and they come in with their contents, and then their contents finds stability with whatever it reacts with. That's why you got red and brown and black and yellow and all these different colors. In opals, you got every color there is, because those are transition metals that come from blood. Blood is the key that makes all the greatest colors. The greatest colors come from blood. Like right here, just right here. It's an artery. You see all these different colors? That's because it's blood. And they turn into yellows and blues, and they make blood makes all the gemstones. All right. Well, carbon is different. Carbon is by itself, but the rest of them are gemstones are primarily silicates with inclusions that are these transition metals. Okay, all of this happened because of dense silica in the ocean waters. And siliceous ooze, which is silica, is a deep sea sediment composed primarily of siliceous silica-based remains of microscopic marine organisms like diatoms and radiotoms. It's a siliceous ooze. It's 2.5 times heavier than water, so it lays on the ocean floor until we were hit by Venus. And then it flopped all through the waters and supersaturated all the waters and created mud fossils, but it also created gemstones. You see this? I reported all this stuff. My DNA tests, CAT scans were all done in 2015. I reported all this to Yale. Well, you know what? As a matter of fact, let me just show you something. This was my first interaction with Derek Briggs from Yale. Now, I said, hello, my name is Roger Spur. Professor Berger requested I contact you regarding mud fossils. All right, because I originally got a hold of Professor Berger. He said, oh, no, you have to go through Derek Briggs. He's the top guy. I said, okay, good. So here's what I sent to Derek. I said, I am working with wet, platy, silicate mud rocks, which are thought not to contain fossils. This is in Connecticut, which he's right down the street from me, basically 15 minutes down the road. I'm in Connecticut, too. And I said, they don't contain bones like the dry desert sands, but they contain actual mud rock copies of the creatures, and some with possible DNA, which I did have done, and yes, it was DNA. The bones turned to stone. That's a stone bone, a bone of stone, stone of bone, bony, stony stone. Now, I said possible DNA, no problem whatsoever getting DNA. I mean, there's a ton of it. Now, here's where I was wrong. I said the encapsulation was quick, which is true, cold, not true, compact, true, anaerobic, true, platy polar silicates, true. The only thing that was wrong was cold. It was hot. It was a hot boiling flood. Now, continuing wet conditions, true. Resulting in microcurrent fossilization, true. The microcurrents were through the membranes, which allow certain things in, not other things. Now, the process is literally electrical replacement, which is nucleophilic invasion. all right, which means these new products come in and push the other ones out. They invade and substitute. So the nuclear invasion of the organic matter. Now, because Ca2 plus, calcium 2 plus, is so reactive in solution, the calcium bone is really quickly replaced with percolates in the wet conditions, which are these. The bone itself, the white bone, is replaced. There is that, you see that right there? That little taste of white, I don't know if you can possibly see that. But there's a taste of white right there. Hold on. There is bone. That's all that's left. It is still bone. Everything else was invaded. And very rare does the bones hold up. I mean, they just don't. They get invaded. And that's exactly what I sent to Derek Briggs. All right, everything I have said here, he has in his paper. Now, this was from March 4th, 2015. 10:20 a.m. Eastern Standard Time. Anyway, I told him everything, how it happens, and that the bones turn into mud rock, basically, and we're working with platypolar silicates, and the replacement happened in these wet conditions, and it was perfect solution, and there's calcium, very reactive, and the bones, they don't last, they turn into mud, stone. So I continued on to say the preservation of soft tissue, however, is almost perfect in some cases. And I mean, when I say perfect, I'm talking perfect, like this piece of meat. That's the fascia, that's the meat. I have ones with blood coming out of them, no problem whatsoever. So I said, if it can be perfect in some cases, and then I sent them the Mudfossil channel to look at it. I said, this process is rare, which isn't true. It is not rare, it's common. And as such, it's not well studied, therefore not well understood by mainstream science. University of Alberta proved the electrical currents. Well, they're telluric currents, they call them. Did they prove it creates mud fossils? I don't think so. But at that time, I thought it did. However, I go on to say, I have a YouTube that describes the process, has examples of perfect fossilization. I appreciate an opinion if you would be so kind. And then I sent all this stuff and so forth. And he just sent back and said, no, that doesn't happen, and forget about it. So I kept sending him all my information and all my YouTubes, and I was upset. So I went ahead and had my stuff DNA tested and CAT scanned and everything else. It still didn't make any difference to Derek Briggs. He still refused to examine it. That's not scientific, my friends. I don't think so. You know, however, the crazy thing is, I sent this to NASA too, because up on Mars, they have the same thing. They have all of the sarcomeres, they have all of the Mars blueberries. It's all biology. And then NASA went and paid Derek Briggs to do a study about this, and he reported basically what I reported. And remember, I said it was quick, and it was from a lot of water and a lot of flood, and the platypolar silicates. The silicates was the big deal, because they don't exist now. They're deep in the ocean. The only way they come up to the surface is when it got hit. And it literally almost stopped the Earth, or could have stopped the Earth from spinning for a day or two. And then all of that stuff welled up. And it created the mud fossils, first of all, because virtually all feldspar, which almost all rocks are coated with feldspar, is aluminum silicates. All right, aluminum silicates. And the reason is the phosphorus, which is the phospholipid membranes, boils down as a decay to aluminum silicates, and the silicates came up from the ocean floor as well. So the three of them are working in concert here, and with the sulfur. Sulfur is a big one there too. So I reported all this to Derek Briggs. And then I said, I have a YouTube, I would appreciate. See Mudfossil process the lung for perfect preservation samples. And this is that lung, which again, DNA tested, And it's been CAT scanned as well. The CAT scan doesn't show much because it's just pretty much solid now. But it's flat because it died laying like this with the heart in the back, showing the aortic arch and everything of the heart, where it was laying on top of the heart. Everything separated because of fascia facilitated fossilization. Don't forget, 2015. My final paper was still in 2015 because nobody would pay any attention. So I figured, well, I'll just write a paper. And I got all the evidence, I got the DNA, I got the CAT scan. Didn't make any difference. Still to this day, it hasn't made any difference.